Welcome. Let's discuss the idea of synthetic division. Let's take a look at the following three examples. Well, let's start with example A. Here we have two expressions that are being divided. The expression of 2x to the third plus 3x squared minus 4x plus 8, it's being divided by the expression of x plus 3. When we are doing synthetic division, the denominator, it needs to have two conditions. First, the highest degree in the denominator, it must be of a value of 1, which we do. Notice that x is raised to the first. And second, the variable in front of x, it also needs to be of 1. In other words, the coefficient of the variable, it is of 1. If we have these two conditions, then we can perform synthetic division. Now let's talk about the setup. Let's take a look at the numerator and let's make sure that the degrees are in standard form. Here the first term is to the third, then it follows to the second, then it follows to the first, and then we have a degree of 0. And when your numerator it's in standard form, what we are going to do, we're going to get every single coefficient and we're going to place it in order. 2 followed by 3, followed by -4, followed by 8. So 2 followed by 3, then -4, and then +8. And then we're going to open an upside down box. And on the outside, we're going to place the opposite of what's in the denominator. Here we have a +3. So let's place a -3 on the outside. And now we're done with the setup. Now let's talk about the process. Let's get the first value. Let's bring that down, which in this case, it is a 2. And what we are going to do, we're going to multiply these two numbers. 2 times the number that is on the outside, -3. Which in this case, the result is -6. And that value, we're going to place it underneath the next coefficient, which is of 3. And now let's combine these two. 3 plus -6, that's going to give me -3. And then we're going to repeat the process one more time. -3, let's multiply with the outside. That is going to give me +9. And that value of +9, let's write it underneath the next number, which is -4. And now let's combine them. 9 plus -4, that is equal to +5. And let's repeat the process one more time. 5 times -3, that is -15. Let's place that underneath the next number, which is of 8. And now let's add them up. 15 plus 8, that is 23. And we are done. The values that we have obtained from our calculation, 2, -3, 5, and 23, are going to be the coefficients of our result. When we were performing our division, notice that the numerator, the highest degree was 3. So from our results, the value of 2 is going to be the coefficient of 1 less, which is x to the second. And then we're going to go 1 lower. -3 is going to be the coefficient of x. +5 is going to be a constant. And the value of 23, this is our remainder. So let's write down our result. The division is going to give us a result of 2x to the second minus 3x plus 5 plus the remainder divided by what we had as division, which is x plus 3. So we are done. Let's take a look at another example. Let's start by checking if we can even perform synthetic division. First thing that we must check is the highest degree on the denominator equals to 1, which it is. And second, is the coefficient in front of x also equals to 1? It is as well. Now that we have checked those two conditions, let's start thinking about the process of synthetic division. But there's one thing that I noticed. When I take a look at the numerator, that there are some variables that are missing. We are missing the variable of x to the second, and we are missing the variable of x. We need those to perform synthetic division. So what we are going to do, we're going to rewrite the numerator. First, let's start with x to the third. It's going to have a coefficient of 1. Then, when we write x to the second, let's give it a coefficient of 0. And then let's write down the variable of x, which is needed, but let's also give it a coefficient of 0. And now let's finish it up with -1. I want for you to convince yourself that this expression that we have just written on the right-hand side, it is the same as the expression that we are given. We are just acknowledging that the variable of x squared and the variable of x had a coefficient of 0. We need those coefficients for our setup. And now the denominator, well, it's x minus 1. So now that we have all the variables in standard form, from increasing to decreasing order, let's perform our setup. Let's get all those coefficients in front of those variables, 1 followed by 0, and then finish it up with -1. And let's put them down inside of an upside down box. And on the outside, let's put the opposite of what we have on the denominator. On the denominator, we have -1. Well, let's place a +1 on the outside. And we are done with our setup. Now let's start the process. Let's bring down the value of +1. And then let's multiply this result. 1 times 1, well, that's going to give us +1. Let's write down that underneath the following number, which is 0. Now let's combine them. 0 plus 1, that's going to give us +1. And let's repeat the process one more time. Let's get the next result and do the same. Let's multiply times the outside. So we're going to get 1 times 1, which we're going to get +1 one more time. And let's combine those two results. 0 plus 1, well, that is 1. Let's repeat the process. 1 times 1, that is +1. Let's write that result underneath the next value, and let's combine them. -1 plus 1, well, that is 0. So we are done with the computation. Now let's make sense of our result. On the numerator, the highest degree was x to the third. So therefore, the values that we have obtained here, we're going to start with 1 less. In other words, the first result that we have here is going to be the coefficient of x to the second, 1 less than the highest degree that we had in our numerator. Then followed by 1 less, which is x, then followed by the constant. And now the last number, this is our remainder. So let's write down our result. We're going to get 1 x to the second plus 1 x plus 1 plus a remainder of 0. But we're not going to write that down. So we are done. And just a little side note, because we had a remainder of 0, then this is an indicator that the denominator is a factor of the numerator. X minus 1 is a factor of x to the third minus 1. We can only make conclusions of factoring when our remainder is equivalent to 0. So let's take a look at our last example. Let's start by checking the two conditions in the denominator. Is a high degree 1? It is. Is the coefficient also equivalent to 1? It is. And because we have these two conditions, then we can perform synthetic division. So now let's take a look at the numerator. Are the degrees in order? And notice that they're not, because we go from x to the fifth to x to the second, and then x to the first, and then x to the second. Notice that in here, we are missing some variables. We are missing x to the fourth, we are missing x to the third. We need them for our setup. So what we are going to do, we're going to rewrite the numerator. Let's start with x to the fifth, which has a coefficient of 1, because we are missing x to the fourth. We are going to write it down, but we're going to give it a coefficient of 0. And we are going to do the same with x to the third. We are missing in our numerator. Well, let's write that down. Well, let's give it a coefficient of 0 as well. And now let's write down what is left. X to the second, then x, and then the constant. Let me move this down a little bit to the left. And now let's place our denominator, x plus 1. Now we have all the information for our setup. Let's start by getting all those coefficients. 1, followed by 0, followed by 0, followed by 5, followed by 1, and then followed by 2. Let's put down an upside down box, and on the outside, let's put down the opposite of what we have in our denominator. We have positive 1, so we're going to write down negative 1 on the outside. So now that we're done with our setup, let's start the process. Let's bring the first value down, which is 1. And let's multiply the outsides. 1 times negative 1, that is going to give us negative 1. Well, that value, let's put it down right underneath the next number in our setup. And now let's combine them. 0 plus negative 1, that is negative 1. For that result, let's write it down underneath it. And let's repeat the process. Let's multiply the outsides. Negative 1 times negative 1, that is positive 1. For that result, let's write it underneath the next number, which is 0. And let's combine them. 0 plus 1, well, that is positive 1. And let's repeat the process. Multiply the outsides, which is going to give me negative 1. Let's write down that result underneath the next number, which is 5, and let's combine them. 5 plus 1, that is 6. Let's write that down. And let's repeat this one more time. Multiply the outsides. That is going to give me negative 6. Let's write that down underneath the next number, and let's combine them. That is going to give me negative 5. And let's repeat this one more time. Multiply the outsides, which is going to give me positive 5. Let's write that down underneath the next number, and let's combine them, which is going to give me 7. Notice that the highest degree in our numerator was x to the 5th. So all these results that we have from our calculations are going to be the coefficients, but we're going to start with one less. If we started with x to the 5th, then the value of 1 is going to be the coefficient of x to the 4th. And let's go down the line. The negative 1 is going to be coefficient of x to the 3rd. Positive 1 is going to be the coefficient of x to the 2nd. 6 is going to be the coefficient of x. Negative 5 is going to be a constant. And the value of positive 7. This is our remainder. So we are done. Let's write down our result. 1x to the 4th minus 1x to the 3rd plus 1x to the 2nd plus 6x minus 5 plus 7 divided by what we had on the denominator, x plus 1. So here we have our results.
Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.